Hi and welcome back to this section where I would like to look at just quickly two more examples for the fixed point algorithms and then move on to the next thing. Okay, now we have here an example where I want to find the root of the equation 2x equals to cos x plus 3. So by now you know the usual way. What we want to do, we want to make this f of x, x equals to f of x, so perhaps we could just write it as it is, cos x plus 3, such that we have this in the form x equals to 5x. Okay, okay, let us just write it like that. Okay, we assume, of course, we have to make those okay, let us leave it as that first. Of course, we have to make sure that this is less than 1 on the interval. Maybe let us take it 0 to pi and then on 0 pi. Okay, so we know that if we differentiate 1/2 cos x plus 3, okay, it should be give us 1/2 will remain there, and then this is negative cos x, negative sine x. Since we are taking absolute value, we can say it is sine x, and then this is a constant, we get a 0. So you can say that, and for sure this is less than 1 on the interval 0 to what? To pi. Okay, yes. So then next would be, yes, to set up the table of, we have n, we have xn, and then we have xn plus 1. Okay, xn, maybe then we can have cos of xn, and then maybe we can have xn plus 1, which is equals to 1/2 of cos xn plus 3, and then lastly you can have the values xn, the errors, xn plus 1 minus xn, the column for the errors. So you fill everything like we have done before, and then try to verify with what we are going to get. Okay, yes, I hope I haven't made a mistake. This is it, this is it, this is it. Okay, so next I will just show you here where it was run. Text editor, yes, this is it. Okay, set the tolerance, and then the initial root, that is pi over 2. It is between 0 and pi, so we can pick half pi over 2, and then the error, and then the count as usual, and then this is 1/2 of cos x, 1/2, a half into cos x plus 3. Okay, as xn plus 1 equals to 1/2. Okay, this one here, yes, xn plus 1 equals to 1/2 into cos x plus 3. Okay, that is what we have here. So we have that. Yes, then the usual, we set, and then we run here. So now next we run, and that is fixed point 3. Okay, so we run, and then here we make sure that you get this root, and I think that is what also is in the notes. Make sure you can get that, and then also try it out with pen and paper. Okay, and later on, after I've given you a few hints, you'll be able to try it, or perhaps you could even try it now with your MATLAB. Okay, now the next example here, which I would like us to finish with, is x cubed equals to sine x. Now for this one here, we wrote two schemes, one which will be convergent and the other which is not convergent. Okay, so you can try it out and check out with the rest of the theorem why one works and why is not, and why the other is not going to work. So perhaps someone could have written one scheme and then say that x equals to sine x over x squared, okay, or another one could have written that x equals to just sine x then the cube root, okay, the power 1/3, right? Yes. So let's try that and then see. Let's see. Okay, I think it is this. So the first one here is this one here, which is x1 equals to sine x to the power 1/3, and then the other was sine x over x squared, that is x naught times that. So you could just try out the logic here and then see which works. So this is, so now we have commented the second one here, so we are running this one here, that is sine x to the power 1/3, and then we see if that is going to work for us. Okay, so let's go ahead. This is 4, and then we see, okay, I think the first one works for us, and we get the root as 0.92 and so on. So let us try out this other one and then see what happens. Okay, comment that and comment that, save, and then try to run here, and then we see, okay, I think we got already errors. So you can know that this one here, even after 25 iterations, then it has somewhere where it's saying it is dividing by 0, so it has failed to converge. So now you can check why this, which one, this worked, this did not work. Okay, yeah, so I have avoided going through everything which we by now already know. So you can check, you go through, you check, is this form, is the form phi of x, its derivative, is it less than 1 on this interval which we are looking at, 0 pi, and so on and so on, and then you confirm everything. Okay, thank you. Anything you don't understand, you can please post in the comments, and you can let me know how to make this better. I hope you have been able to pick something here. Alright, thank you, and see you in the next video.